Your AI isn't actually thinking about which tool to use. It's basically guessing, and it works anyway. And that's the wild part. So when you use ChatGPT or Claude, or any modern AI that can browse the web, write code, or do math, you probably think there's some smart decision-making happening inside. Like, the model looks at your question, evaluates all its options, and picks the best tool for the job. Logical, right? Clean process. But that's not what's happening at all. Let me show you how it actually works, because once you understand this, you'll see why these systems are simultaneously way more fragile and way more impressive than people think. First, some context. These modern AI models, the ones with what we call tool use or function calling, they're trained on massive amounts of text. GPT-4, Claude, Gemini, all of them. They're not running some internal algorithm that says, okay, user asked about the weather, I need to activate the weather tool. That would be too simple, and it would require hard-coding every possible tool into the system. Instead, they're doing something much weirder. They're predicting what text should come next, and sometimes that text happens to be the name of a tool. Here's the actual mechanism. When you ask an AI to use a tool, what's really happening is the model is trained to output something like XML tags or JSON or structured text that says, I'm now calling the calculator, or I'm now searching the web. It's not actually calling anything. It's just writing out the words that describe the action. Then, a separate system outside the AI, we call this a wrapper or an orchestrator, reads what the AI wrote, sees the tag or the request, and actually runs the tool. The AI output is just text. It's the same process as writing instructions for a human. You don't think, you just predict the next word. And here's where it gets strange. The model isn't really choosing in any conscious sense. It's learned patterns from training data. If you show it thousands of examples where users ask questions, and the training data has the right tool being called in response, the model learns to output the tool name. But it's not running a decision tree. It's not weighing options. It's pattern matching at a statistical level. The model has learned that certain question patterns correlate with certain tool outputs, and it's just continuing that pattern. Now, you might be thinking, okay, Ark, but if it's just guessing based on patterns, how does it work so well? That's the surprising part. It works because the patterns in its training data are really good. The model has seen millions of examples of correct tool use. So when you ask it something new, even something it's never seen before, it can interpolate and predict the right tool call with pretty high accuracy. It's not magic. It's not thinking. It's statistical pattern completion at scale. But here's the catch, and this is important. Because the model is just predicting text, it can make mistakes that seem bizarre. Sometimes, a model will confidently output a tool call that makes no sense. It'll try to call a calculator for a question that needs a web search. Or it'll make up a tool that doesn't exist. Or it'll call the same tool multiple times in a row when one call would have been enough. These aren't bugs in the logic. They're prediction errors. The model predicted the wrong sequence of text. There's also a weird phenomenon called hallucination of tools. The model will sometimes output a tool call syntax perfectly, but for a tool that was never defined. It's like the model learned the pattern so well that it can generate tool calls even when the tool isn't real. It's trained to output tool calling shaped text, and sometimes it does that regardless of whether the tool exists. So why does this matter? Well, first, it explains why these systems are so brittle in certain ways. If you change how you phrase your request, or if you ask it something that's statistically different from its training data, the model might suddenly pick the wrong tool or no tool at all. The system isn't robust because it's not actually reasoning. It's interpolating. Second, it matters because it tells you something about the limits of current AI. These models aren't making decisions the way a human expert would. A human programmer would think about the problem, understand what information they need, and then choose a tool. An AI model is just completing a pattern. That's powerful, but it's also fundamentally different from reasoning. Third, and this is the part that blows people's minds, it means that the ability to use tools isn't actually built into these models at all. It's a behavior that emerges from training. You could take the exact same model and train it on different data, and it would learn to call different tools, or call them differently, or not call them at all. The model itself doesn't have an innate concept of tools. It just learned to output certain text patterns. There's also an interesting implication for how we should think about AI capabilities. When we say an AI can use tools, What we really mean is this model was trained on data where tools were called, and it learned to predict tool calling text. That's very different from saying the model has a tool use capability in some deep architectural sense. It's a learned behavior, not a built-in feature. Some researchers are now experimenting with better ways to get models to pick tools. Instead of just training on examples, they're building in explicit reasoning steps. They'll prompt the model to explain why it's picking a tool before it makes the call. This forces the model to generate text that describes its reasoning, which often leads to better tool selection. But even that's still just pattern completion. The model is just predicting text that sounds like reasoning. There's also the question of whether this method is even scalable. Right now, tool use works because the model has learned good patterns from training data. But as tools become more specialized and diverse, the model might not have seen enough examples to learn the right patterns. At some point, pattern completion might hit a ceiling, and we might need actual reasoning. But here's the thing. Even with all these limitations, it works. It works remarkably well. A model that's just predicting text can still call the right tool, in the right order, with the right parameters, most of the time. That's kind of amazing when you think about it. It's a reminder that intelligence doesn't require consciousness or explicit reasoning. Sometimes, statistical pattern matching is enough. So next time you use an AI that searches the web or runs code or does math, remember, it's not thinking about which tool to use. It's predicting the text that describes using a tool. And somehow that's enough. It's fragile, it's weird, and it's one of the strangest things about how these systems actually work. If you want to actually understand how AI works under the hood instead of just hearing hype, subscribe. I break down one of these misconceptions every few days, and this channel is basically built for people who want to know what's actually happening, not what sounds impressive.